So let us explain today's class. So in the previous class, we studied the delays. So three different delays are associated in the Verilog. That is, we studied like for input to the output of primitive gauge. Which are the delays? Those delays are rise delay, fall delay, and turn-off delay. We've seen those things with a small example. Next, what we will do? Let us study for values of each delay. So what is the values of each delay will be here. So the Verilog will provide an additional level of control of each type of delay mentioned in the above actually, like the minimum value, the typical value, and the maximum value. So how it can be done for each type of delay, like for each type, keep it in mind, each type in the sense we are having previously rise, fall, turn off. Now here we are having for each type of delay, we have three values. Like example, first I say rise delay was the, in the rise we are having three different delays are associated. That is rise minimum value, rise typical value, rise maximum value. Same the way fall delay. Fall minimum value. Fall typical value. Fall maximum value. And the term of delay also turn off minimum value, turn off typical value, turn off maximum value. Set values. Any one of the values can be chosen at the start of the simulation. So here this will be specified like this. Minimum typical used to model whose delays are within a minimum and max because of IT fabrication process variation. Let's see what is the minimum value. Minimum value is a minimum gate. So the minimum value is the designer expect the gate to have a minimum gate value. During the IT function time itself, actually, this will have the variation. Now, then what is the typical value?
The screen is not visible.
Delay value that expects the gate to have. What is the typical value? Then that designer expects the gate to have. Now let us see minimum. Page is not visible.
No, sir. Your voice also breaking. No, sir. Your voice also breaking.
One. What about others?
The screen is
Yes,
not
sir.
visible and voice
Can I
is
able to hear?
Yes, sir. In between, the voice is breaking, sir.
Is it visible? The screen is visible?
The voice is breaking. No, sir.
Voice is
no
breaking.
the screen.
What happened? See now, see the screen. What you are getting now? Now it's visible. Screen is.
Yes, sir.
Yes, sir.
Yes, sir. Now it's
Yes. Okay. Okay. So here, in this, after that, once the class gets over, so in your chat box, so whatever we done in the class, that video will come over there, that we can download within some 30 days actually. It will be there. You can download that video also in the chat box. After end of the session, you will get it. You can try out that also. Maybe your side, maybe network problem is there. So because here it is correct. So let me recap what we done now. So here we are going to study the value of each delays. So value of each delays in the sense, previously we studied 3 different delays, that is rise, fall and turn off. Each and every the delay will have 3 different values, like the minimum value, typical value, maximum value. So rise has these 3 values, the fall also has these 3 values, turn off also has these 3 values. So now here we'll see one by one we see. So now in this, there is a method of choosing a minimum, typical and maximum value may vary for different simulators or operating system, because based on that only, so we can choose the minimum, typical, maximum. For Verilog Excel, the value chosen by specifying the option as like this, like a plus max delays, maximum and plus and plus minimum delays runtime actually. So if no option is specified, the typical delay value is the default. Keep in mind, if you are not specifying option of the delay by system, by default it will take the typical delay. So it will allow the designers to flexibility of building 3 days value for transition in the design. Now let us see here how the syntax will be there. Say example, even we are using the primitives like gate name. This gate name is nothing but a primitive. So it can be either and or XOR, buffer or buff if one of it 0. Then delay, here we see bracket, minimum delay, maximum delay. Then followed by here the instance name, then output comma input. Now you have to keep it in mind, when you now already ready. So the gate name here, if specified, it will take for throughout the program, it will take that transition only. But if you are having 2 values, then it will consider as rise and fall. Now each and every delay has these 3 values. So now you can see, if I specify like this, it has only 1 delay. So now you see the example. Let us see, I will show the example for each and everything. Example for minimum, maximum, typical delay values. For 1 delay, because we are having 3 delays are the rise, fall, typical. How it will specify? See, and hash. See, within the bracket you see 4:5:6. What does it mean here? 4:5:6 means it can be any delay. That is the meaning of that. This is any delay. See, this is any delay. This one. We say any delay, but this 4 is related to minimum delay, the 5 is related to typical delay, the 6 is related to maximum delay. See here, very important, we have to separate the delay with the colon. See here, colon, you should not use comma. It is any delay, it can be any delay. And then A1 out, I1, I2. Now if you are having 2 delays, see here, 2 delays. Now the minimum delays for rise, fall and turn off. The minimum delays for these delays, minimum value of, that is a rise minimum, fall minimum, turn off minimum. So rise minimum is 3, fall minimum is 5, turn off minimum is, what is the turn off minimum? It is nothing but, as you know, the turn off is the minimum of rise and fall. That is the minimum of 3, 5. That is nothing but your turn off delay. Already we studied. Same. If the delay, that is rise, typical delay is 4, fall typical delay is 6. Then turn off typical is what? Minimum of rise and fall. That is minimum 4,6. Then maximum delay. Rise maximum is 5. Then fall maximum delay is 7. Then minimum of rise and fall 5,000 and 3:4:5 is 1 delay, 5:6:7 is 1 delay. So it's nothing but what? This 3:4:5 is nothing but what? It is nothing but a rise delay actually. So I can say this 3 represents rise minimum, this 4 represents rise typical, this 5 represents rise maximum. Keep it in your mind this. So let me explain once again. So 3:4:5 means this 3 represents, because as you know 3:4:5 total together I can say that is nothing but rise. This is rise. Comma actually what? Okay. See here, this is nothing but rise comma fall. The rise delay has 3 values, fall delay has 3 values. Rise has 3 values means minimum, typical, maximum. See here, minimum 3, typical is 4, maximum is 5. Next fall. Fall minimum is 5, fall typical is 6, fall max is 7. See, we not specified turn off here. We not specified. Why? Because the turn off is the minimum of rise and fall. That is the turn off normally. Now we will see 3 delays. See the same 3 delays. So if minimum delays rise, fall, turn off is specified here. Here we are not 2 days, the turn off will minimum. So only we are not special or the turn off max. Max or turn off max. Now it will be like this. It will be this way. Rise. This is what it will be. See, now the rise has 3 values. So what are those 3 values? The rise has 3 values. That is nothing but which one? This only. Rise minimum, rise typical, rise max. So rise minimum is 3. You see, rise minimum is 2 and this is 2. Then rise typical is 3. Then rise max is 4. Same the way second is fall. Fall minimum, fall typical, fall maximum. Next is this is time turn off. This is supposed to be turn off actually. This should be turn off actually. So turn off minimum, which one? This is the turn off actually, correct? This is the turn off actually. This is the turn off. Turn off minimum, turn off typical is 5, turn off maximum is 6. See, this is what here we shown. So all the 3 days. This is one very important question. The examination they will ask. You should write this. So now, how we can invoke this in the Verilog Excel simulator using the command actually? How we can invoke? So you have to assume that the module with the delays is declared in the file in your test.v file. So in that we need to invoke the simulation delay. We need to invoke. How we can invoke delay? So max means test space plus max delay. Say automatically we'll get the answer. What is the maximum delay of that in the file? Next, if you want invoke delay, you have to use like this plus minimum delays. If you want to invoke typical delay, you need to use like this. So these are the commands to invoke Verilog Result Simulator with this help of keywords. Now, now here we are writing simply, we are implementing the expression is this: out is equal to A into B plus C. This is the diagram is done here. In this, the specified, see, this gate, the specified hash 5 means the gate delay of this AND gate is 5 delay. Then the OR gate delay is 4 actually. So now 2 time units are there. So the inputs A, B, C and the output is there. So now what we need to do, we need to write a code with including the delays here. So let us start. So the module is they given us D, that is the module actually. So let us write module D, out is BC, input ABC. Next, port declaration. The port declaration, the inputs are ABC, output is out. Then there is a wire here, so wire E, wire, yes, that also. Next, we have to instantiate the primitive gate to build this circuit. There is a delay over here, 5, 4 and all. So let us write AND. First, this is the AND gate, right? So let us write AND hash. How much delay it is? AND gate has 5. See, here is specified. So we have to say 5 within the brackets. See, hash 5. Then A1. What is the output is? E. Input is AB. So we return here. So that is the delay of 5 on gate A1. Next you will see OR gate. OR hash 4. Because the OR gate with the delay is hash 4 is given. So OR hash 4 O1. Here also what is that? Out, that is output comma E comma C. E comma C, that is a delay of 4 on gate O1 end module. So this is the program. Now corresponding program you need to write the stimulus. That test bench you need to write. Then instance module D call D, you call the D from there. So D1 output, input out, comma A, comma B, comma C. Now let us give the inputs. See, initial begin. We pass A, B, C value, then after some certain amount of delay, we change the value of A, B, then target dash from the current. Now from this, can you say what is the simulation time? Can you this?
Screen time, sir.
Answer this. The people who are in this class answer this question. What is the simulation time?
40 screen time,
See the chat
sir.
box?
40 screen time, sir.
Yes. So it is. So those who know the answer, just you can click on this poll. this question, which is in the chat box. Okay, now you may have one simple, there will be a doubt in this, because in this program also we given the delay here, then even we use the delay in the test bench also, then how it will produce the output? Waveform will be generated based on this waveform, based on delay. Okay. Even though inbuilt you are having the gate delay is there, like OR gate and AND gate, that is #5 and #4, that is 4 delay is there. So now we need to see how we are getting the output. So let us see. So this is the waveform here. As you know, values A, B, and C initially you assigned the values. Okay. But what the E will be created. See here. So the initial delay. See here. This initial delay time of 0 A B is there. As soon as E value is C, but when I will get E value, I will get after 5 screen time units only I will get. So until 5, in the sense until 5, the E is the output. After it gives the output, as 2800 will be 0. But see, the next set of things changing when? After only changing. After 10 it changes, but when you 28 output produce in the sense, after 10 plus 5. See this? There is a delay concept. You have to check this delay actually. Even we need to include that delay also. Based on that only we will get. This is waveform for delay simulation. So these are the some work for you. So we need to create your own 2-input Verilog gates like OR gate, NOT gate, and NAND gate and all. So like you need to use only NAND gates. So everything you have to use only NAND gate you have to use. So develop the basic gates and you need to write the test bench program. That is one of the exercise question for you. Even examination they may ask. So you should be able to write There is some set of questions are there in the exercise which is solved in the notebook also. So even some question they may ask like this: 1 bit full adder. When such expression is given over there, they may ask you to use only the gates. See, this is the full adder using only the gates. That is the AND gate and the OR gate. We are not used any XOR gate here. You see, we converted everything to basic only. Its form of, I can say, inverted I, A, O. That is inverter, AND gate, O gate. Or from the reverse, if I see O, A, I, in the form of O, A, I actually. This is A, O, I also we can use. A, O, I means AND or invert. That is A, O, I. From the above diagram, we written the program for full adder. See, in gate level only. This is gate level already we written. Next, this is one of the very, very important question. This question, that is the logic diagram for RS latch. They will give this diagram in examination. They will ask you to write the coding for this. So you have to take us yourself to take it from your book or take an assignment to this. You have to write with the delay only. So this and all everything given. This is the stimulus also is given. Next, this is the one more important question. See, we need to design. So I hope this is very simple. I can say this is NOR gate. This is also NOR gate. The NOR gate with the delay 1. This is also with the delay 1. See this NOR gate delay 1, delay 1. So you know the gate level, then corresponding test bench here written. Next, we need to monitor. Very, very important. As I said earlier, we must use this monitor for all the program, monitor and display. So keep it in mind, you must write. Next, very important this question. This is a very important question. So examination is repeat. See, you need to design a 2-to-1 multiplexer using buff if 0 and buff if 1 below. So the delay specifications for gate B1. This is the gate B1. Then B2 are follows. In bracket they given rise, fall, turn off. Minimum is 1, rise typical is 2, right maximum is 3. Then fall minimum is 3, fall typical 4, fall maximum 5. Turn off minimum is 5, turn off typical is 6, turn off maximum is 7. Now what you need to do, apply the stimulus and test the output value. Now you see, this is the diagram which is showing here. It's nothing but a 2:1 multiplexer with the help of buffers. That is, you see from this figure only easily you can identify this is buff if 1, this is buff if 0. As you know the operation buff if 1. What is the meaning of this buff if 1? If this control signal is 1, then only the input will be positive output. But buff if 0 means if the control signal is 0 only, the input will be positive output. Now we'll see how it will act as multiplexer. When selection line is 0, it has to select IN0. When selection line is 1, it has to select this. See, now I will apply S is equal to 0. If I apply S equal to 0, which buffer will work? This buffer will not work. Only this buffer will work. Then output is equal to in 0. When S is equal to 1 means this buffer will work. This will not work, then output will be equal to IN1. So something like 2:1 multiplexer. Now we need to write the coding for this. How we can write the coding? Let us write the coding for this. So now let us write the coding. How we can write? First you start with the module mux 2:1. Output is out. The inputs are IN1, S, IN0. Right, the inputs are IN0, IN1, S, output is out. Then now you see buff if 1 first. Buff if 1. Now after the what you have to ash, we see the delays are given. How we can write the delay now? What is the order of the delay? You can write the order is rise, fall, turn off. Next the rise has 3 values, means minimum, typical, maximum. So how it will come now? First. So here only I will write. I am not writing. It's just I want to show here. Buff if 1 hash. Now tell me what is the delay for buff if 1? Can anyone answer for this? First
1:2:3.
so rise means 1. Is typical, rise maximum. Next, fall minimum, that is 3 colon 4 colon 5, come on. Next, 5 colon 6 colon 7. Now what's the instance name? The instance name is B2. See, B2 is given. Next, you need to write the output. It will be like out, comma, again 1, comma, yes. So this is what next by 0. What will be the delay now? For this also same delay only applicable. That is 1 equal to 5. Then instant name is what? V1. Then here out, comma, in 0, comma, 0. So okay, I yes. 1 3 1 3 5 2 4 6 1.